6.2, adding and subtracting rational expressions. So in 6.1, we simplified them. Now we're going to add them and subtract them. So we know rational expressions are just fractions with variables. So we're going to treat them just like fractions because that's exactly what they are. So in order to add fractions, right, we need the same bottom, or as we say, the denominator. So adding or subtracting rational expressions with a common denominator. To add or subtract rational expressions with common denominators are to add or subtract the numerators and write the sum or difference over the denominator. All that means is, all right, we have our example 1, we have 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. So you see our bottoms are the same. Since they are the same, we're just going to add the tops. So we're going to add the tops. We have 4p plus 3p, which is 7p. And then we have negative 3 plus 8, which is positive 5. And that's over the denominator that they both share, which is 2p plus 7. Another way that we can do this, we know we're going to add them all. So let me show you another way. So we have the same denominators. So since we know we have the same denominators, we're going to add them. So we know we're going to add the tops. We're going to add the tops. So they share the same denominator, is 2p plus 7. And we know we're going to add the tops. So we have 4p minus 3 plus 3p plus 8. And we can combine like terms here. So we combine like terms. We have 4p plus 3p is 7p. Sorry, that's supposed to be a plus. 3. Nope, sorry. Gosh. That's a minus. I'm not going to take that out. You're just going to see it. I was looking at the wrong thing. Anyways, negative 3 plus 8, we get positive 5. And then that's over our denominator. So how do we know we're done? We're going to see if we can factor. So looking here, on the top, 7 and 5 have nothing in common. And remember, this is one whole thing. That's one whole thing. They're not identical. So bottom 2p7, they have nothing in common. That's our final answer. All right, let's do this again. So we have 8y over y minus 2 minus 16 over y minus 2. They have the same denominator, so we can just combine like terms on top. So on top, we have 8y minus 16. And that's over y minus 2. So how do we know we're done? Let's see, on top, do they have anything in common? They do. On top, they have 8 in common. So I can take 8 out. And when I take 8 out, we're left with y minus 2. Because 8 divided by 8y is y, and 16 divided by 8 is 2. And that's over our denominator of y minus 2. We have two identical parentheses. We have two identical factors, y minus 2, y minus 2. So all we're left with is the number 8. Identifying the least common denominator of a rational expression. To add or subtract rational expressions with unlike denominators, you have to change them to equivalent forms that have the same denominator, a common denominator. That involves finding the least common denominator or common denominator of the original expression. Before finding a common denominator, factor each denominator completely. Alrighty, so we're going to find the LCD of each of these. You can find the LCD when you're working with math or the common denominator. But right now, lowest common denominator. Let's find it. So we need to factor our denominators. That's our first thing. We don't care about the top. The top can be anything, but bottom needs to be the same. So we need to take out our denominators. So we're going to take out 6y, And 6y, that is 6 times y. Technically, it's factored. It is. 6 times y is factored. Then we have 4y plus 12, and we can factor that because we can take a 4 out. And when we do, we're left with y plus 3. Now we can find our common denominator, our LCD. So what we want to do is we want our numbers outside of parentheses to match. So what does that mean? I want 6 and 4 to be the same number. So 6 and 4 have 12 in common. Then on the outside of parentheses, I have this y. So we need to have a y. Last but not least, we have y plus 3, so y plus 3. Let's keep practicing. All right, so we only care about the denominators. Let's take them out. So when we take out the denominators, we have x squared plus 4x plus 3. And then our next denominator is x squared plus 10x plus 21. So we have to factor. So let's factor each denominator. We'll have x plus 3, x plus 1, and then we'll have x plus 3 and x plus 7. So the common denominator is where they both are identical. That means we want pieces of both denominators in each of them. So let's see if they share anything. They do. They share x plus 3, so I'm going to only write it once. They don't share anything else. Since that is the case, we still have to add it to our common denominator because they all have to match. So if the green one has x plus 1, that means the purple one should have x plus 1. If the purple one has x plus 7, that means the green one should have x plus 7. So that's our LCD. We practice with that all through chapter 6. So this isn't the first time we're going to see common denominator. We're going to keep practicing. That's all. We're going to just get through it. Practice, practice, practice. All right, moving on. So we take our denominators out. All right, now we need to factor each denominator. So we can factor this one. We can take a 5 out. So when we do, we're left with x squared minus 1. We can factor one more time because x squared minus 1 is a difference of squares. So we can factor that into x plus 1, x minus 1. All right, let's factor our purple one. So, or pink, I see it both ways. It's pink and purple to me. So when we factor it, we have x minus 1, x minus 1. Now let's do our common denominator. So let's see, do they have anything in common? They do. They share one x minus 1s. They only share one of them. They only share one pair. So we cancel those out. We have x minus 1. Let's see. What we have left over is x plus 1. Another x minus 1. And I don't know if you see it, but do you see this 5? We also have to include the 5. So our LCD would be 5 times x minus 1 squared times x plus 1. It's squared because we have 2 of them. Alrighty, so last one for LCD. These look very similar in the denominators. So we have x minus 3 and 3 minus x. We can't factor anything. But remember in 6.1 how when you divide them they simplified to -1? Go back to that example in 6.1, you'll see it. So it has to do with that. So I hate the way that's the blue one, 3 minus x, blech, it looks horrible. So let's rewrite it. We have -x plus 3. We can move that around too because I don't like -x. So we can take the negative out and we're left with x minus 3. So our LCD, they both share x minus 3. But then we have this negative. So negative x minus 3, and that's our LCD. Let's use this. It's easier to use it than it is to just flat out find it. So let's add or subtract with unlike denominators. Example 3. So we need to add these. In order to add these, the bottoms need to be the same. So we find something that I just like to call the common denominator. So the common denominator, just multiply them together. Do not find the LCD. That takes too much time. Just multiply them together. 7a times 6a, that's 42a squared. Okay, awesome. So I need my bottoms to be 42a squared. So you know how I multiplied them together? So times 7a times 7a times 6a times 6a. I multiplied them together. See what I mean there? That's why I do it that way. So on top, we have 16a times 15. That's 90a over 42a squared. Plus 8 times 7a is 56a over 42a squared. Now I can add them because the bottoms are the same. So I have 90a plus 56, and that's over 42a squared. Sorry, 56a. I forgot the a there. A. My bad. We can combine like terms on top because they're both a. So 90a plus 56a is 146a over 42a squared. I can cancel out because a squared, I can get rid of one of them. So we're left with 146 over 42a. We can simplify because they're both even, so we can divide by 2. And we get 73 over 21a. We are done there because 73 is prime. Alrighty. We need our common denominator. So we're not going to multiply these ones together because this is that same one, right? That weird one it's identical, right? So remember, this is the one where we switch the weird looking one. Right, we're going to switch it around. So we have negative 2x plus 6. We take the negative out. We'll have 2x minus 6. So that's going to be our common denominator always when you're working with something like this. So you see how they're identical, right? Except the numbers are flipped. Your common denominator will always be negative and then the one with x first. So your common denominator is negative 2x minus 6. So let's multiply. So for the bottom one right here, the only thing that it's missing is the negative. So negative on top, negative on bottom. And so we rewrite our expression, and we just rewrote 6 minus 2x, what we did here, we just rewrote it. So our common denominator is negative times 2x minus 6. So it's good to go. That one is negative 2x minus 6. So all we need to do to the left one is multiply by negative because it's already 2x minus 6. So on top, we have negative 5 over negative times 2x minus 6, and that's minus 3 over negative times 2x minus 6. Now that they have the same denominators, we can go ahead and simplify the tops. So we have negative 5 minus 3 over negative times 2x minus 6. We keep simplifying, so on top we have negative 5 and negative 3 is negative 8 over negative times 2x minus 6. We know negative and negative, those create positive. And let's see, are we done? 8, that's just 8. Can't, this is a number, can't do anything yet. So 2x minus 6, do they have anything in common? They do. 2x minus 6, they have a 2 in common, so we can factor it. So we have 8 over 2 times x minus 3. And right here, there's no plus or minus. Since there's no plus or minus there, we can cancel out 8 and 2. So 8 divided by 2, we're left with 4. Our final answer is 4 over x minus 3. You can put the parentheses on the bottom if you want. You don't have to. All right. So first thing, factor. Just factor, factor, factor. If you can, factor, and especially the bottoms because we need them to be the same. They're not the same. So we do nothing with the tops. Let's factor the bottom. So we can factor that into 3x plus 4, x minus 2, plus, all right, let's factor this bottom. We can factor that into 3x plus 4, x minus 1. So now that the bottoms are factored, we can find our common denominator. So they share 3x plus 4. And then we write what's left over. Whatever they don't share, we just write what's left over. So x minus 2, x minus 1. So now we write like what's missing. So if we look at our common denominator for the first one, 3x plus 4, x minus 2. What it's missing is x minus 1. To the right, we have 3x plus 4 and x minus 1. The only thing it's missing is x minus 2. Doing that gives us the common denominator. So let's write what we have now. On top of our first one, we have x minus 1 times 9x plus 2, and that's over our denominator. That's plus 7 times x minus 2 over our denominator. Let's FOIL the top and distribute the 7. So when we FOIL the top, we get 9x squared minus 7x minus 2 over our denominator. We can distribute 7, so 7x minus 14. Alright, now that they have the same bottoms and everything is FOILed and simplified, we can add the top. So on top we have 9x squared minus 7x minus 2 plus 7x minus 14 all over our denominator. Combine like terms on top, so we have 9x squared, the 7x's cancel, and negative 2 minus 14, we get negative 16 over our denominator. We can factor the top because it's a difference of squares. So we can factor the top into 3x minus 4, 3x plus 4 over our denominator. Cancel out like factors, so 3x plus 4, 3x plus 4, and what we're finally left with is 3x minus 4, x minus 2, x minus 1. Remember, never multiply bottom. Let's factor. Alright, so we can factor the bottom into x minus 3, x plus 3, difference of squares, plus 3 over, let's factor again. We can factor that into, sorry, I'm blanking. X minus 3, x minus 3. And then that's minus 1 over x plus 3. I can't factor that, so it's just x plus 3. All right, let's find what our common denominator is. So there's a pair of x minus 3's right here. There's a pair. So x minus 3. And then we have a pair of x plus 3. And then last we have this x minus 3 to worry about. So we're going to make sure all of the bottoms match the common denominator. You rewrite the problem. I don't have to. Okay, so we need the bottoms all to match. So here we have x minus 3, x plus 3, so it's missing x minus 3. All right, the middle one, we have x minus 3, x minus 3. It's missing x plus 3. All right, next, we have x plus 3, but it's missing x minus 3 and x minus 3. Right, it needs to match. All right, so let's simplify this. On top, we have x times x minus 3 over our denominator. How many x minus 3's do we have? 2. So I'm going to write 2 now. And that's plus 3 times x plus 3 over our denominator. And that's minus x minus 3, x minus 3 over our denominator. All right, let's simplify the tops so we can distribute and FOIL. So x squared minus 3x plus 3x plus 9 and that's minus x squared minus 6x plus 9. Now that the bottoms are the same, we FOILed, we have everything like nice and neat, we can add the tops. So everything over our denominator. So we have x squared minus 3x, positive 3x plus 9, and then we have this negative, so we actually have to distribute the negative. So negative x squared plus 6x minus 9. Let's combine like terms. X squares cancel. 3x cancels. Negative 9, positive 9 cancel. Only thing we're left with is 6x. So we have 6x over our denominator.